Hello, in this video we are going to see how to conduct hyperparameter tuning with TensorFlow in R. For this task, basically we need two scripts. One script that describes the model and a second script that describes the process of hyperparameter tuning. The first script is similar to what I did in the previous video, where for example, we fitted a logistic regression model, and then the first step was to define the model structure, then we compile the model, then we import the dataset, and then we fit the model. Additionally, we could include other steps. For example, we could evaluate the performance of the model on the test set. But the main change now is that we are going to use flags for doing hyperparameter tuning. So the first step here in the script that describes the model is to define with these function flags the hyperparameters that we're going to tune. For example, I'm going to do regularization. So first I create a flag, in this case numeric, for this L2 parameter that is going to be the kernel regularizer when we do L2 regularization. So then we define the name of the parameter and also a default value. That will be one example of a hyperparameter that I want to tune here. A second example will be, for example, if I want to do a hyperparameter for the learning rate. So I create a second flag. This is going to be also numeric, and then we enter the name for that hyperparameter and a default value. Then when we have that argument in the script, then for example for the regularization, then I insert that flag with that name. So flags $L2, because this is called L2 here. So here I insert that flag. And for example for the learning rate, then that's going to be inside the optimizer. Then I enter that flag here by its name. So that's basically the main changes that we need to do in the script that describes the model. The second script will be the one that controls the hyperparameter tuning process. So first we define the values for the hyperparameters that are going to be tuned. In this case I have two hyperparameters. So the first one is L2, and then I enter possible values that can be evaluated. For example, 0.0001, 0.001, and 0.01. And same for the learning rate, I enter possible values that can be evaluated. So in total I will have 3 times 4 combinations, that is 12 combinations. So the step that runs the actual hyperparameter tuning is this one over here. We have to use the tfruns package, and then we use this function tuning_run. So the first input here will be the script that describes the model. As you can see here, this is the name that I have given to that first script. And then we enter the name where the results are going to be saved. In this case, let's say _tuning. And we enter the values for the flags. In this case, this list that I created here for the possible values for the hyperparameters. As I said, this is going to evaluate 12 combinations of hyperparameters. In other cases, we may have more hyperparameters that we want to tune, and then we may have more possible values for each of the hyperparameters. So at the end, we may end up with a grid that may have tens or hundreds or thousands of possible combinations. In that case, it may be better to just run a sample of those possible combinations. Let's say, for example, 10% or 20%. So instead of doing a full test of all the possible combinations of hyperparameters, we can do just a portion of them. And that will be done randomly. So that could be beneficial when we have a very large grid of possible hyperparameters combinations. Alright, so let's try running this. This script is ready. And also here I have added, for example, a callback for early stopping, and then that would be helpful for preventing overfitting. So although I'm saying here that this training should run for 200 epochs, actually if the training finds that there is no improvement in the performance of the loss metric for the validation dataset after 20 epochs, then that training is going to stop. So I'm going to add that. That's another addition in this new script. And then we are ready to run the hyperparameter tuning. So basically we read the list of possible hyperparameter values, and then we load the tfruns package and we run this line of code. Here is going to ask if we want to proceed with tuning run. So this is basically because it's asking you if you want to run just a sample of the combinations. In this case, this is a small number of combinations, so I'm going to say yes or just hit enter here, which is the default value. The message here is that it's going to start with the iterations or with the modeling. In this case, the first run is the first out of 12 combinations, and these are the flags that, and this is going to be saved in this directory. We can also see that in the working directory there is a new folder underscore tuning, which is the name that I enter when I define this value for the runs underscore dir argument. So inside the tuning folder we are going to find that folder that they mention here, and here all the runs, one for each of the combination of hyperparameters, is going to be created. Okay, once the hyperparameter tuning is done, we can visualize a summary of the results. To do that, we would use the ls underscore runs function, and we enter as value for the runs underscore dir argument the folder where we have saved the results of the runs. So let's run this code and let's open that table. We are going to see that this is a data frame with 12 rows and 24 columns with information. So this is a kind of a large table. Let's open the table. We see that we have information such as the folder where each of the runs was saved, and we have 12 runs, one for each of the combination of hyperparameters. We have the evaluation of the loss function and the accuracy metric on the training and validation sets. We have the flags. So these are the values that were used in each run as values for the hyperparameters. We can also see that we have the information about the epochs. So I set 200 epochs to be run for each of the training of the models, but here, because I inserted a line for an early stopping callback, then not all the runs were conducted until the 200 runs. So some of them were finished before. For example, this one with these values of hyperparameters was only conducted for 23 epochs. And then we have more additional information about the models, the loss function, which was binary cross entropy because we're doing logistic regression, and the script that we use, and so on. Some more information about the models. Okay, so that's a summary, and that's pretty useful, but we can also take a look at the results sorted by a given metric. For example, here we can say, let's use the ls underscore runs function to order the data based on the values of the accuracy metric on the validation set, and we set the order to be decreasing. The results are taken for this folder underscore tuning. So we see now that the results are sorted here. The best model, for example, got let's say we have the metric accuracy, metric value accuracy. So this would be the accuracy on the validation set 0.6369, which was this run. We can also do that manually. We could open the table and then click on the metric value accuracy, and then we sort the data decreasingly, and we see that the best model was this one in the 12th run. So that would be a way to sort the results, but we can also take a look at each of the runs. For example, with the view underscore run function, we could take a look at the latest run, for example, or the best run. For example, for the latest run, we use this latest underscore run function as value for the run underscore dir argument, and we are going to use the viewer that comes from this tfruns package. So let's open that, and this is pretty useful because we have here a good amount of information about each of the runs, and we have three tabs, one with the summary, another with the output, and another with the code. So in the first one with the summary, we see these plots where we can examine how the loss function varies for the training and the validation sets across epochs, and also we see in the lower part of the plot we see how accuracy changes through epochs for both the training set in blue and the validation set in green. Besides that, we have information about the model. This would be the structure of the model, and then we have additional information. In the output tab, we see the same plot as before, but we also can see the console output that was printed for each of the runs. So we have that information, and for example here we have the scores that we got because we asked the code to evaluate the model on a test set. Besides that, we have the code that is the same script as we saw before, the script that describes the model. So this is a very useful way to explore our runs. And for example, we could also take a look at the results sorted by one of the metrics, for example accuracy. So we could say take the results and sort them by the value of accuracy on the validation set and select the best one, which would be the first one. So this would be the model, so we would use the same viewer, so let's do that. And this will be the best result. We have the result for the accuracy on the validation set, which was 0.6369, and then we have the information about the model, we have the output and the code. Okay, we can also compare runs. So let's say that we want to examine the differences between two of the runs. In that case, we would use this command, compare underscore runs. So for the first argument, let's say runs, we could enter, let's say, the latest two runs. That would be using the ls underscore runs function and using this argument latest underscore n. And we would use the same viewer from tfruns. So in this case now we are examining the values for two of the runs. We would get information about these two folders, and then we have data for the runs, the metrics, and then here we will show us what's the difference between the flags in those two models. So the first one is running the L2 hyperparameter with value 0.001, and the second one is running value for the hyperparameter with 0.01. And then we will examine the difference in the plots, showing how the loss metrics and accuracy metrics are changing across epochs. So here we have the plots, and then here we have what are the differences in the console output. Okay, another way would be to enter, instead of the latest two, we could enter the numbers that correspond to the runs that we desire to see. So for example, we would use the subset argument, and then we enter a vector with the two values that corresponds to the number of the runs. We again use this compare underscore runs function, and then we use the viewer from tfruns. The same thing, we are going to see here the tables to compare the runs with the information of the metrics, the information in the about the flags and the difference, and the plots. Now finally, when we have examined our results, then we can try to select the best model. So that in that case we would use the ls underscore runs. We would sort the data using the accuracy metric in decreasing order, and those runs are in the underscore tuning folder, and we select only the first one. So we can say that as the best run, and then we would retrain the model using the best parameters. So in that case we use the training_run function. We enter as first input the script that describes the model, and then we use the flags. So for the flags, these will be the best values for each of the two flags, the two hyperparameters that we are tuning here. So for the L2 hyperparameter, we take this table, which is the one that we have here, and then we extract the value for the L2 hyperparameter first, and then the value for the learning rate hyperparameter. And then with the training_run function, we retrain the model. Okay, so when the training is done, then note that in the script I have added a line where the last step is to save the model as a file with format HDF5, and that will be a file that is going to be created on disk, as we are seeing here on the folder. So because of that, I can retrieve that file and then load that model, which is my best model. So I'm going to save it as my best model, and after that I can continue working with this model and do predictions and so on. Okay, thank you very much for watching this video. Hope you like it. If you are interested in learning more and practice with this script and the dataset, then I'm going to leave a link in the description that you can access to get the scripts and the dataset files. See you in the next video.